Our objective is to know how to build hydrocarbon structures applying UPAC rules and to know how to construct hydrocarbons when given a UPAC name. What is UPAC? UPAC is the International Union of Pure and Applied Chemistry. It is an international scientific organization not affiliated with any government. The UPAC strives to advance chemistry in part by setting global standards for a name, symbols, and units. Nearly 1,200 chemists are involved in UPAC group projects.
So, what are hydrocarbons? Hydrocarbons are organic compounds made of hydrogen and carbon. Hydrocarbons are divided in mainly three groups. These three groups are alkanes, alkenes, and alkynes. So, the main difference between alkanes, alkenes, and alkynes are their type of bond. The bond is in between all the carbon atoms. The alkanes have all single bonds, the alkenes have one double bond, and the alkynes one triple bond. Alkenes and alkynes may have more than one bond, but they must at least have one double bond or one triple bond. Before showing you how to name hydrocarbons, well, alkanes, I need to show you some prefixes needed, which are meth, F, prop, and bot. Depending on the number of things that we have, we will use one. There is the numbers. So in functional groups, we will have the suffix "-al", and here, for example, we have one carbon, so it's methyl because methyl stands for one, meth stands for one, and then we have ethyl, which is for two. Then it's propyl, and this one, isopropyl, as you can see, it starts from the middle, not from the ending. Therefore, it's called isopropyl. It has different functions and properties, therefore it has different names. These prefixes will also be used for alkanes. So the first rule for naming alkanes in the UPAC rules are first identifying the parent chain, which is the longest chain of carbon atoms. Then we will need to number the carbon of atoms depending on the side which is closest to the substituents. The third step is to identify the substituents, which are the ones that I already mentioned. And the fourth steps are to name the substituents in alphabetical order, indicating their position. So for example, if we have methyl and ethyl, we will name first ethyl rather than methyl. And the number 5 is to name the parent chain. The suffix will be "-ane" and the prefixes will be the same. These little rules, like comma separates numbers from numbers, and the little line separates numbers from letters. So if we have an example, we will have maybe methane, which is with one carbon atom and all single bonds. So now I'm going to show you how to name alkanes. Here is an example. So we need to show the longest chain, and here we have a chain of 6 carbon atoms, which is this one, and you have to name them depending on which side has the substitute more closer. So here it's 1, 2, 3, 4, 5, because in the other side we will have the first number to be 3. The next step will be to identify the substituents. We can see we have only one carbon atom. Therefore, our functional group will be methyl. So we have achieved the first 3 steps, and the fourth one says we need to name the substituents in alphabetical order, indicating their position. Therefore, okay, we will name them. We have just methyl, so we will name it first. We have methyl on the position number 4 and on the position number 2. We will write 2, 4, line methyl, and since we have 6 carbon atoms, we will put X, and our suffix is "-ane". I will show you another example. We need to first find the parent chain. So this is the longest chain of carbon atoms. and we will count to which side we should start numbering for the step 2. And we will do it left to right because it's 4, and right to left will be 5. And then we will need to identify the substituents. So we have here 1 methyl because it has only 1 carbon, and we have 2 carbon atoms, so it's ethyl. The step number 4 says name substituents in alphabetical order indicating the position. We have methyl and ethyl. Ethyl is first, therefore we will write 4 line ethyl line because it separates numbers from letters, 4 line methyl. At the end, we will name our point chain, which is octane because we have 8 carbon atoms in it. So we first need to identify the parent chain, which is the longest chain of carbon atoms. Then we will name our parent chains depending on the side which is closest to a functional group. This time we have it from right to left. Then the third step says we need to identify the substituents. Our first substituent is methyl because it has 1 carbon. The second one is ethyl because it has 2 carbons. The third one is methyl because it has 1 carbon. And the fourth one, it's not propyl, even though it has 3 carbons. It's isopropyl because isopropyl has the carbon attached to its point chain on the middle. It has different functions, so we need to name it differently. It's an isomer of propyl. Then we will name the substituents in alphabetical order and indicating their position. Ethyl is first, then it's isopropyl, and then it's methyl. But since we have 2 methyls, we will put a comma in between the positions of our both functional groups. The last step will be named the parent chain, which is octane because it has a parent chain of 8 carbon atoms.
I'm going to show you how to do the steps to draw structural formulas for alkanes. First of all, for alkanes we must have single bonds so it can be done correctly. As you can see in the formulas, I used only single bond formulas. And to do a structural formula, first you need to have the name of the substance, for example butane, or 2-methylbutane, or ethane. These are the ones I used for this video. For example, for butane, first you need to know that butane means it has 4 carbons. As you can see, 1, 2, 3, and 4. This one is the condensed structural formula. And for this one, you need to have 4 carbons, and then you fill these spaces with hydrogen bonds, so all the carbon bonds are used correctly. As you can see, this carbon has 4 bonds. It uses 3 with hydrogen and 1 with the other carbon. In the structural formula, you have the carbon with 3 hydrogens and the next carbon with 2, because it already has 1 with the other carbon and 1 with the other carbon. Same with this one, and this one is the same as the first one. This is how you do a structural formula, and I'm going to show you another example with this, which is 2-methylbutane. In this one you have CH3, CH2, CH, CH3, and CH3. Using a condensed structural formula is much easier because you don't have to use all these bonds. You don't have to draw them. You just draw the element and the number representing the bonds with this element. Well, in this case you have CH3, which means carbon with 3 hydrogen atoms, and then this next one with 2, and this one, as it has in here a bond for this one, which it says 2-methylbutane from this side, then it means it has another carbon atom in here, and then 3 hydrogen atoms. And this one, it only has 1 hydrogen atom on this side because it already has the other 3 bonds with carbons. And in this side we have ethane, which is 2 carbons In this case, both of them have 3. Sorry, my bad. Which means they have the carbon atom and then 3 hydrogen atoms in bonded to it, and 1 carbon atom bonded to the other carbon. So this is the way you do a structural formula, and I hope you like.
Alkenes are a family of hydrocarbons containing a carbon-carbon double bond. And these are 2 examples. And the steps to name a hydrocarbon are: first, identify the longest chain of carbon atoms that contains the double bond. Name the longest chain as an alkene, then convert the suffix "ane" to "ane". Number the longest chain to give the carbon atoms of the double bond to smallest possible number. Indicate the possible position of the double bond in the longest chain. Identify, name, and the number of any substances as is done for alkanes. Alkynes is the least one triple bond between the atoms in the molecules. These are 2 examples, and the steps is: first you add the "ine" suffix that indicates an alkyne. Second, the longest chain chosen for the root name must include both carbons of the triple bonds. Then the root chain must be numbered from the nearest triple bond carbon. Then the smallest of the 2 numbers designated the carbon atoms of the triple bond is used as the triple bond locator. 5. If the several multiple bonds are present, each must be assigned a located number. Double bonds precede triple bonds in the UPAC name, but the chain is numbered from the nearest multiple bond, regardless of its nature. And 6. Because the triple bond is linear, it can be accommodated in rings larger than 10 carbons. Aromatics. Aromatics hydrocarbons is a hydrocarbon with alternate double and single bonds between carbon atoms, forming rings. These are 2 examples of aromatics, and the steps are: use the general formula prefix plus root plus suffix. If there is only single bonds and no branches, add aromatics. Aromatics is a hydrocarbon with alternating double and single bonds between carbon and forming rings. These are 2 examples of aromatics, and the steps are: first, use the general formula prefix, root, and suffix. Second, if there is only single bonds and no branches, add the word cyclo to the beginning of the word of the name. Third, if one of the branches attached, that the carbon number 1 body is aromatics. Aromatics is a hydrocarbon with alternating double and single bonds between carbon atoms forming rings. These are 2 examples, and the steps are: first, use the general formula prefix plus root plus suffix. Second, if there is only single bonds and no branches, add the word cycle to the beginning of the name. Third, if one branch is attached, the carbon in the number of 1 but the number does not have the part of the name of alkyl group is added to the beginning of the name. Then, when 2 or more branches are presented, any branch can be position number 1. And last, if a double bond is presented in the ring, follow the rules for naming alkanes. The double bond determines the position of carbon 1 and the number assigned to any branches that are presented. Now I show you a table for each class, a function group, and some examples of each one.